Welcome back to Centerline Designs, everyone. My name's Cole. This is our all aluminum Snowcat build, and in today's video, we're finally gonna go ahead and pour our polyurethane final use drive sprocket and machine some hubs that'll connect that sprocket to our hydraulic wheel motors. Stay tuned, it's gonna be a heck of a video. If you're wondering what the Snowcat is, it's a winter tracked vehicle. I've been working on it for over 2 years now. It is one of a kind, designed by myself, mostly built by myself, and we've gone ahead. It has a Volkswagen turbo diesel in it. It's got a set of hydraulic piston pumps that drive hydraulic wheel motors, which makes this a hydrostatic drive vehicle and zero turn. It can spin on its own axis if you really had to. In a bunch of previous videos, we finally got all this track building done. It was hundreds and hundreds of hours of labor and welding. We sent the grousers off, got them hot dip galvanized, and pretty much have the tracks completed. We need to go ahead, get these sprockets done and the hubs to mount them to the wheel motors done so we can get the track length finalized, get all that stuff together. And then there's really just a little bit of hydraulic work to do and just finish up some engine stuff. So I really wanted to drive it this winter. I don't know if that's gonna happen. I gotta start getting ready for our house lifts soon, which I've been working on some implements for our loader and different things like that. And eventually I just have to switch gears entirely. So we'll see where we get. I love working on this rig and I really wanna drive it. It's been 2 years and I want the payoff. But with all that being said, let's go ahead and start working on these sprockets. Well, it's the time we've been waiting for. Let's go ahead, get this mold assembled. We need to put some silicone, a light layer of silicone between all of the mating surfaces. And then we need to screw the top split down, and I got some big elastic bands to hold all this together while the silicone cures. So we're gonna go ahead, we're gonna get the silicone in here today, get it all secured, and then I'm gonna put this aside for a couple of days, let that silicone set, and then we'll pour the mold another day. But it is coming soon, and then we're gonna go ahead and start machining the hubs and everything like that these mount to, which should be pretty handy. So what I'm gonna do is, I originally thought I'd put these on here, but since the holes are in a circular pattern, I'm gonna move them over a little bit, and that way that should help strengthen the mold as well. So we'll stagger the joints. Get this loosely put together here first. Alright, well I gotta work in the shop today, so I'm gonna put this down on the floor here. Everything is lined up pretty good. I went ahead and just made sure to silicone any little gap. The epoxy is pretty hot and it only has 2-minute working time. So we're gonna let this set up real nice. And then hopefully this works. Just to make sure it stays flat. Okay, it's been several days. The silicone has completely set and I tried to seal it up as best I could. I just took this inside and measured it with water and it was approximately 4.5 liters. So we'll mix up 5 liters of polyurethane just to be careful. I also checked with a level that we're quite flat here right now. So with this completely set and ready for some polyurethane, we're gonna go ahead. So this mold release, you just spray it in, brush it in everywhere, give it another spray and let it stand for 5 minutes and then you're good to put the epoxy in. Okay, so the polyurethane we are using today is from Specialty Resin. This product was actually mentioned to me in the comments from someone who repurposes, recoats Snowcat sprockets. And it's a Shore 65D hardness. I ordered it in black. And Shore 65D is somewhere between a caster wheel and a hard hat. It's extremely abrasion resistant, impact resistant. I did a test sprocket with this stuff and you can't wreck it. So it's gonna be really interesting material to work with. Now, the working time on this is 2 minutes. So from when the time you mix both parts together and get it mixed up, there's 2 minutes to get it in the mold. And it demolds in 30 minutes. So it's a pretty hot mix. You gotta have everything ready to go. So I'm gonna go ahead and measure out equal parts of each in these little disposable cups and then dump it all into a bigger pail, mix it up with a mixer, and then let's pour, because once I get going, I'm not gonna have a lot of time to work with this, so let's get to it. Even smartened up and got some gloves on. Okay, so let's start by getting one part into the pail, and then I'm gonna pour out enough in other containers. I don't know, I'm making this up as I go. Liter and a half. Two liters. All right, here we go. I'm gonna measure out all this second part and get it pouring. Here we go. Okay, here we go. First actual final use sprocket being poured. Kind of smells like chocolate milk. Oh, it's getting thick already. That epoxy was setting up as I was pouring it. Like, no word of a lie, it's 2 minutes. And we got it all in. Hopefully a little bit of squiggles settle down, but that doesn't even really matter. No word of a lie, less than 10 minutes from mixing. It's hard already. Yeah. It's a hot mix. That's cool. I can't wait to demold this. That's pretty much set up over here, and this sprocket got hot. But I was playing around with the pail, and I figured I'd just mix up the next batch, you know, when the time comes in here. But this is too satisfying. Like it'll just come right out. Doesn't stick to the pail. That's cool. I might as well go ahead and start removing some of these screws. I don't know what the best plan of attack here is. So we need like a spatula. All right, well, one piece can be reused. You know what, I'm gonna wait on the rest because the epoxy was so warm, it was affecting the molds here. So we're gonna have to go ahead, let this cool down because I may have to reprint a couple. Oh, I didn't wanna do that. Okay, let's leave it a little longer. Well, it's fully cooled down now. Back on it another day. Let's get this mold off. This is gonna be the interesting part. Didn't ever assume this would be easy, but I am trying pretty hard to not break these. If we can get one out, it'll all be easy. It seems like this red one wants to go. Yay! Okay, let's get back to the table. There we go. There we go. There we go. Honestly, I think it's as good as I expected. Oh, this looks awesome. This is probably $250, $300 in epoxy right here. There we are. We got ourselves a drive sprocket. Oh. I guess we should see if it fits. That would be the coolest thing to check here. Here's the true test. I think that is going to work really nicely. Cool. Well, there you have it. We got that successful sprocket, and it engages on those tracks pretty nicely. It's a little hard to tell still, but I think it's going to work wonderfully. We are going to have to reprint a couple little sections of mold, though. The heat buckled them a little bit more. I probably should have printed them with a little more structure inside to avoid that, but I was not expecting the epoxy to get that hot. So anyways, a little learning there. So if we're ever casting a larger volume of epoxy like this again, let's put a lot of infill in those 3D printed molds, and that should help to keep it from buckling as much. And even the molds that have a little bit of buckling, It's not a big deal. The sprocket is gonna wear in, it's gonna find its happy place. So if it's not absolutely perfect, that's fine. This is a wear item, so we really just need the teeth to have worked properly. Everything else will be all right. So, oh, milestone. That's a huge milestone. I need to sit on this for a little bit because it worked. I mean, how many hours and hundreds of dollars have I spent making these? I don't want to count, but pretty cool. Okay, we are on to the next step. We're gonna have to switch gears and we're gonna put some steel on the CNC table, and we need to cut out a disc that this will shoulder and mount onto, and then through bolt with a plate on the outside. And there's some other little things we're gonna do on there to help give the sprocket some backing, and not just a thin little piece of metal that's gonna be on here. Will increase the amount of support that the polyurethane is gonna have. That's gonna require a bunch of CNC cutting and then a bunch of machining, and we're gonna be machining right to about the limit of our lathe. So I hope we can get it done, but it should work out pretty good. So after spending a bit of time getting the actual measurements off of our part now, I have the dimensions for the faceplate, and I came up with some measurements for the sleeve that'll go over the wheel motor that welds onto the faceplate. I found some old bolts that are gonna work great, so we're gonna go ahead, cut those down. We gotta do some boring work on them. We're gonna cut a keyway in them with the lathe. Never done this before, so hopefully it works. And then we'll go ahead and CNC cut out the faceplate and put all the extras on it. I want to avoid chucking stuff up in the lathe too many times and having to change setups, because it just takes a lot more time. Okay, I think that makes sense. You'll see it happen as it happens. So let's go ahead, get these in the bandsaw. All right, let's get this faced off. 1/2-inch drill bit, and we're gonna try and drill through this whole thing. We're only gonna bore out part of this, and then we're gonna cross drill in to allow a relief for when we cut the keyway. I hope it works. With our 1/2-inch hole successfully drilled all the way through, we're going to drill out a little over 3 inches and then bore it out to our final size, and then we'll go cross drill that hole. Alrighty, well, I am proud of myself, and not just for wearing a glove while holding something hot, but we got this roughed out, and I thought in my head, you know what, maybe I shouldn't take it to final size. Because part of me just wanted to machine it to dimension, but I have to weld this to the faceplate, and there's a lot of chances for error or warping or twisting, and if we leave a little meat on this, if that stuff happens, we machine it to size after it's cooled down from all the welding, and then we're fine. It doesn't matter. I don't want to machine something to size and then go screw it up when I apply heat and weld and do a bunch of things. So yeah, I know I've made that mistake in the past. I'm not doing it this time. So this is just rough. It's got a little bit of machining left to do, but we need to go ahead. We'll cut out those face plates, get some welding done, put all this together, and then take it down to a nice, true parallel, concentric, all those things at the end. Not getting me this time. Well, it took me a little bit of time to get all that catted up, but I think I got it all. So let's cut some parts and fingers crossed they work. We got the faceplate cut out and cleaned up, and one thing I noticed is my slots to be able to bolt it up on the faceplate on the lathe didn't cut quite accurately enough, and they're not gonna accept the 1/2" bolt that I was gonna use. So we're just gonna have to make up some other T-nuts and figure that out, use a little bit smaller hardware. Not that big a deal. So I think you might be starting to see what I was trying to do here. I wanna widen up the material so there's more surface area for the sprocket to press on. Just spread those forces out. And instead of going with like 1" thick material, which would have been pretty expensive and way too heavy, we're just adding material where we need it, and then we'll go ahead and machine all this down to the right sizes in the end. So we have a couple of rings. This big outside ring helps to shoulder on the big OD here, so it'll widen that up a bit. And then these smaller rings go on the opposite side and help to shoulder up to the smaller diameter. So I'm just gonna get these clamped on. Doesn't have to be perfect. That's why I wasn't too worried about these cuts being super accurate. I actually overcut everything to allow for some machining in the end. So big thing now is just go ahead. We're gonna clamp this down, put some tacks on the outside, which will get machined off, or just grind them off. We're gonna go ahead and be using our Everlast welder with a dual shield. It lays in really nicely. It penetrates through mill scale really, really well, and it just leaves a pretty nice smooth finish. So let's get that set up, clamped in, and get welding. timer turned itself off because it was too hot, and that's gonna have to cool a little bit. But while that's cooling, let's go ahead and get some things set up on the lathe. With the faceplate on the lathe, we need to go ahead and make some really wide nuts. We're gonna take some flat bar, drill and tap it for the bolts, and we will have our 4 places to bolt that hub face on, and we'll get it all true, and then we'll go ahead and machine a bit of a shoulder for our sleeve to weld on, and then we'll just keep going through the steps. I think this video might get broken up into 2 parts because there's a lot of work here and it's gonna take several days, but anyways, we'll keep going. Okay, well, chucking this thing up on the faceplate isn't going to be as easy as I thought. I didn't really think about the diameter of this and that we had to deal with, so we need to go ahead and actually space it off a little more than I was planning, but I think it'll work out. So let's see if I can do this. Alright, so that's coming rising. All right, moment of truth. All right, folks, well, as you can see, we got this hub face mounted in the lathe. I even got a center put in it. It took a little bit of work. It was a bit finicky to get set up, but now that it's set up, it's very rigid. I think it's going to machine really nicely. But I'm all out of time today. I'm going to have to split this into 2 parts. There is a lot more to come, and I think it'll make a whole other second video. So in part 2, we're going to go ahead, finish some of this machining to get the sleeve welded on. Once all that cools down, we can focus on getting some of the final dimensions to size, board out to size, cut that keyway, get it mounted on the rig. We still got to through drill and tap the bolts to hold the sprocket on. So there's a lot of other work to come. Like always, it takes longer than I think it does, and you know, we had a couple of issues along the way, but it's nothing we can't solve. So thank you so much for watching. I really hope you enjoy this video. It's really neat. I'm doing things that I've never done before. I'm kind of making it up as I go, but I think it's working out. So thanks for watching. We'll see you in the next one.